Wonderful. Well, thanks so much again for having me here. And this is an exciting series. I'm looking forward to attending the other talks. And thanks so much for giving me the chance to kick it off. So I'm going to be talking about two main talks today. Let's see here. But before I do that, I'm going to give you just a little bit of context about a couple things at UT Austin. And then I'll talk about this first work on content moderation and the second work on aggregating complex annotations. So at UT Austin, I'm on the leadership team of an 8-year, $10 million grand challenge we have across the whole university about trying to design a future of artificial intelligence technologies to meet society's needs and values. And so, as I said, this is a university-wide initiative with a lot of great things happening. And so in some sense, you'll see the work that I'm doing with content moderation, for example, as sort of trying to think about ways in which we can make sure we're doing things that are supporting people in the kind of work they do. I'm also in an information school. I come from a computer science department by background, so I'd never heard of these things until I went out on the job market. So I always feel the need to help people if you haven't heard about them. You know, you have computer science, engineering departments where you build, say, the systems and hardware traditionally. You have psychology and sociology departments where we traditionally study people or how they work in groups. And these information schools are really, as Jake Wilbrock put it, the place where people and technology meet. So a lot of the really exciting work in human-centered computing is happening at these information schools, not only in the United States, but around the world. And you'll see that also influences the work I do today. So with that, the first work I'm going to talk about is this paper we had at the AAA HComp this fall, just presented about a month ago. Let me just jump into it before not skip the title. So content moderation is a huge issue today. So social media platforms, if you think of Twitter or Instagram, Facebook, YouTube, tons of great user-generated comment, and it really sort of has democratized information sharing. Unfortunately, you know, some types of content are unacceptable or may cause harm. So you have this problem in trying to sort of detect and filter out this kind of content. And so examples might be adult content, depictions of violence, offensive language, misinformation, fake news, this sort of stuff. What is considered acceptable varies very much by platform or by region. One example I always like to share is years ago I worked at Crowdflower, where we were providing some content moderation services. And for one customer, it was okay for a man to have a shirt off if he was in an outside area like a park or beach, but unacceptable to have a shirt off if he was indoors. Whereas for another customer, you could never have a picture of a man with his shirt off. So these things are quite subtle by customer, by platform, by region. And there's further issues about sort of how we manage free speech and issues like content moderation, content removal and remediation. So just even yesterday, there was a last day of a 2-day conference at Yale looking at sort of these challenges of trying to do global content moderation. And Facebook put out a really nice report about 2 months ago about some of the challenges of dealing with content moderation at scale. So the scale of content moderation, just to give you some quick infographics, Facebook removed in the first quarter of 2020 over 100 million kinds of these inappropriate content. You can see of all kinds of various types. YouTube does this as well. And interesting, you know, some of the stuff is also things like self-harm. So detecting when people might be also at risk and providing interventions to try to help them. So why can't we just use AI? Like this is the classic thing. If we have, you know, automated systems to do this kind of spam filtering, why can't we just detect inappropriate content? The biggest challenge is that essentially errors are considered unacceptable. You know, what's the cost of showing one person a terrorist video that's very graphic in violence, or showing a child a pornographic video? So there's very high cost of errors, which means you have extremely high accuracy requirements that are really challenging to get through purely automated machine learning methods. We have continually evolving content, different kinds of things that people are uploading, and as well as moderation policies. And as I mentioned, there's regional variants, issues of culture, and of course, adversarial attacks where people adapt the kind of content they're posting to try to circumvent moderation policies. So this is part of a larger backdrop where AI systems are often advertised or perceived as fully automated. You know, if you're an innovative startup in Silicon Valley trying to sell an AI solution, you don't typically want to advertise the fact that often human labor is typically required behind the scenes in order to make this work. And there's this whole theme of scholarship talking about this notion of ghost work or invisible work, or the idea that instead of automation, what we really have is heteromation, this combination or symbiosis of human and AI systems, where you really need human labor to sort of make these systems go the last mile. And so just give an example, there's something like 100,000 human content moderators working around the world today. Rough numbers, 15,000 at Facebook or 10,000 at YouTube. Another thing to remember is there's no free lunch. So even if you're using AI, the training data for the AI had to come somewhere. So you still had to have human annotators go and label this data. Hopefully this was just created already through the moderation practices, but often companies now that are doing a new startup company that doesn't have any history is still paying for more data to be labeled. So you get this sort of human exposure to this stuff, both on the training side and at the runtime side. So I come from crowdsourcing human computation as a research area, and we're all very excited about the things that this enables. So one of the, an article that was by Amazon before its time, this was 1 year after Mechanical Turk launch, talked about the fact that suddenly, if you can put human computation, human intelligence into software systems, a whole new class of innovative business applications are possible. The idea is you enable people who are freer to innovate because now you're no longer limited by the bounds of AI. Suddenly you can use human intelligence at runtime to get sort of arbitrary human level capabilities. How exciting is this, the kinds of things that you can do when you can use human computation at runtime? But then starting around 2012, I first became aware of this issue of the human work in content moderation and talking about some of the really difficult kind of material that the moderators were exposed to and some of the effects they were experiencing from this work. And so this has started to really get a lot more traction in the last couple of years. So there was an extensive report by Cambridge Consultants, who's commissioned by the UK's telecom regulator, I think, talking about sort of the psychological effects and that, the people who do this can experience PTSD. And there's lots of sort of other examples of this out there now. There have been lawsuits against at least both Microsoft and Facebook around content moderation. Casey Newton has been doing a lot of really extensive reporting on this, again, in the past couple of years. And of course, it's not just PTSD. There are a lot of other lesser effects that go along with this, and I can say more later if there's interest. Another thing to think about is it's not just the exposure itself that's the problem, but a lot of the work environment. So you might ask to what degree the people doing this work are provided, appropriate mental health or other resources. But even simply if you're working in sort of like a call center situation where you're under high pressure to get a large volume of work done with certain accuracy requirements, that additional stress comes from that, adds on top of the sort of exposure risks. So what's this great irony that struck me at the time is, we in human computation who were so excited that suddenly we could use people in the loop to kind of do this last mile where the AI falls short, suddenly we have a task that's like the last thing we want people doing because it's emotionally disturbing, but people are filling this void because the algorithm isn't good enough. And so I had this as a problem, actually, I put to students in my crowdsourcing class for a number of years where none of us really did anything about it. But then a couple of years, I had a couple of students who got excited about this and ran with the idea. So this was a short paper we had at HComp a couple of years ago called Who Protects the Moderators? And the idea was, could we reduce the emotional labor of this impact of the image moderation without compromising the accuracy and efficiency of the annotators doing the work? So we have this demo, and I did not queue this up well, so let me grab it quickly and do that now. Okay. Great, so here is a quick run of our demo. So we start with some image that's really blurry, and then we give you different ways to interact with it to reveal the minimal amount you need to in order to do the work. So for instance, in the click interface, you can click parts of it and whatever, oh, I think this is because I rescaled it, it's off here. Anyway, we'll ignore that. So you click and just the parts you click on are revealed. I'll try a reload to see if this, yeah, that's better. Yeah, so just the parts you click on are revealed and they stay revealed forever. Another mouse over thing, as we move the mouse around, only the parts where the mouse is are revealed and only temporarily. So you can just pass over something quickly and just see it and then it goes away. Or we have a slider one where you can start with a deep blur and then gradually reveal more of the image this way, again, full control. So this was what these students did a couple of years ago. And so we presented that work in progress, but there was no results. There was no evaluation of this at the time. We had proposed this study to measure both the accuracy, efficiency, and the psychological effects, but we didn't actually run the study. And so just to say a little more here, so in the past couple of years, there's been a lot more work talking about this notion of trying to mitigate exposure in order to improve moderators. So in May 2019, so we did this, yeah, we did that study, we presented it at HComp in July 2018. So in May 2019, a story came out about Facebook giving these notions of people sort of this similar blurring or the opportunity to mute videos. And the idea was that in partway two, just giving people greater control helps sort of irrespective of, in addition to sort of actually blocking the exposure, giving control itself is something that helps people deal with the material. There's also been a lot of reporting from Chris Harrison, who's a psychologist at Facebook, who's talked about, you know, one of the questions, if anything keeps up at the night, is trying to know how much exposure there is and what sort of we can do to sort of mitigate it. And another statement from Facebook talks about this challenge all these companies are facing right now, which is that they have large volumes of content that has to get moderated at certain scale. And then how do we sort of find the balance between that and resilience for the people who are doing the work? Also, as a side note, I'll mention, so when COVID happened, a lot of these centers where this work was getting done got hit pretty badly. And so a number of them shut down. And so AI had to do a lot more of the moderation work. So there were some challenges that way. Another thing was there was a statement by Mark Zuckerberg talking about the fact that while other Facebook workers could go home, content moderators still had to come into the office. So in addition to the usual exposure effects they had both the risk of coming in and getting exposed to this virus and the added stress about whether they were going to get infected at the same time they were doing all this other work. So industry in general is moving towards establishing best practices and providing controls. Again, this is from Microsoft in 2019. You can find an example of they started having an interface where, again, they would have blurring and these black and white controls. So typical ones, again, are these grayscaling, muting of videos, blurring. It's not well understood how effective, though, these practices are. There really haven't been studies. So the first one that we're really aware of is a year ago at HComp from Google. Two researchers presented a report where they looked at grayscaling and static blurring. And they did see that grayscaling, reduces harm. And so long story short, we had this work that we started basically inspired around that time to kind of go back and finally go and evaluate the tool that we had developed back in 2018. So in our setup, we did this work with Mechanical Turk workers. The Google study was actually done with real content moderators they have at Google. We did this as academics using this mechanical workforce as a surrogate workforce. And our task was basically, we asked them to say, is this content safe for general audiences, or is it something else? Does the person look like a real person or an animal? And imagine that you were a professional moderator. Would you allow this content to be posted? So these official guidelines that these companies use may be 50, 100 pages or more. We weren't going to try to have workers try to learn those kinds of distinctions. And so we just had it as simple as, is this the kind of content that you would allow to be posted? So things we measured were, in terms of psychological effects, positive and negative experience. So this Spain 5-point Likert scale of did people experience negative, positive emotions, positive and negative affect, a 7-point Likert scale about the kinds of emotions people were currently feeling, emotional exhaustion, and a notion of usefulness and ease of use. And so, long and short is we pulled the set of sort of standard measurement techniques out of the psychological literature, along with sort of traditional UX, HCI metrics around ease of use and usability. In terms of content, we had a mixture of sex and nudity, just generally graphic, violent content, you might think, and safe content. And one manipulation we did was to look at realistic content versus synthetic content. So this might be, for instance, an anime kind of cartoon violence, for instance, and ways in which people might have different emotional reactions to that versus realistic content. So we presented people a random sample of 60 synthetic and real images across these categories. This is our total data set. So we had 180 of these images we used for the evaluation. Again, balanced across synthetic and real images. We divided these into groups, balanced over the different classes, again, of sort of violent, sex, and safe content. We had 20 hits, 5 workers per hit. Workers could only do 1, so we didn't have any learning effects. We required the adult qualification. Workers had to have a reasonable approval rating. And we paid workers at a rate of $7.25 to hour when you look at time task and the amount we paid. So we measured these 2 key things, performance. So more or less, if people chose to do this work, could we enable them to still do their work accurately and efficiently while reducing any psychological impacts of the work? In terms of measuring things like clicks and mouse movement, several years before, we had released an open source package on collecting these kinds of analytics on Mechanical Turk. So here's the citation and then GitHub for that if you're interested. So we used this open source package to collect clicks and mouse movement as workers completed the task. So if you start to look at our first results here, so here we have accuracy, and you start with our control with no intervention. And then you have sort of fixed blurring. So we blur a little bit or we blur a lot. And you see that as you just sort of blur and you don't have any interaction, you start to get less accurate because you can't see what you're doing. But when you give people the slider or you give them these click or hover ways that you can, with mouse over, reveal, we see that essentially the accuracy the mean accuracy is unchanged. You're back in the same region again. And in terms of time, really the time is not really affected either. So the long and short of this part is we are doing this intervention without impacting the accuracy or time in any meaningful way. If you think about effort, and we can measure effort in terms of the number of clicks or the amount of mouse movement, again, you don't really see significant differences except in the click interface where you're required to click to reveal things. And if you measure the number of clicks, this interface, of course, requires a lot more clicks than the others. But roughly, we're seeing similar effort across the different designs. In terms of perceived usefulness or perceived ease of use, the control is actually pretty good here to start with. We do see that the slider is basically around the same or just slightly better than the control was. Also, when we look at perceived ease of use, then we have sort of all of the interactive ones are in the same ballpark, and probably hover and slider are slightly better. In terms of comfort, slider is sort of perceived to be the most comfortable. And you can see either this very blur one where you can't see anything, or the slider one where you don't see anything at first unless you start to unblur it. These are the 2 that are perceived to be the most comfortable, whereas the ones that reveal more are less. So more measurements, positive, negative experience. We have the positive experience here in green and the negative experience in blue. So you want more of the positive, less of the negative. And so the control here is in the far left. And, long and short, you don't see too great of differences. We see the slider, for instance, is slightly better. and the click and the hover we're kind of in the same ballpark, let's say, as the control here. In terms of overall experience, here's our control again on the left. We see the slider is a little bit higher than the others, and some of the other ones are kind of in the same ballpark in terms of that measurement. So overall, so here's a measure of 7 states of emotional exhaustion. So we give them 7 statements about how kinds of different ways you might feel exhausted, emotionally exhausted. And here then smaller is better. So we want least exhaustion. And in terms of emotional exhaustion, Huffer is almost always the best model. We see again, this one that's highly blurred that you just can't see anything is also perceived as low exhaustion in terms of burnout. I think these are the last 2 general ones. So positive affect, let's see. Negative, here's our control, negative in blue, positive in, I guess this is a dark orange. And again, slider seems to be the one that shows the greatest difference here. Click and hover both really minimize negative relative to control. And you can see hover and click also both have a higher median. And just for time, I'm going to skip the last one. So overall, when we looked at all of this, it seems like hover is probably the best one to suggest in this case. So if you look at sort of, again, these operational effects, and you kind of see overall between slider, click, and hover, there really wasn't much difference in performance, as I mentioned. In terms of effort, click seems to be the one that makes you click a lot. So that maybe isn't the best in terms of effort. In terms of usability, slider was slightly better than hover in both usability and ease of use. And then these different measures of well-being, comfort, experience, exhaustion, affect. Hover was sort of, hover was the clear winner for comfort. It was slightly worse than slider for positive experience, best for negative experience, best for exhaustion, and the same sort of as the control, better than slider for positive affect. So hover has basically significantly lower emotional exhaustion with comparatively high accuracy. And so if the goal is to keep accuracy, reduce emotional impact, then we recommend hover. So this is the wrap-up slide on this part of the work, and I'll stop and take questions after I finish this. This is, again, after the HComp paper from the previous year, one of the only studies we know of that's really looking at these kinds of design interventions and evaluating to actually see the level of impact they have in terms of enabling people who choose to do this work to do their jobs quickly and accurately with less effect. So the Google paper from the previous year had only evaluated a static blurring interface, which the moderators didn't like. They said it actually became them dizzy. As opposed to this, with this interaction where we let people control the blurring in 3 different ways of interaction, we do see a very different conclusion than the Google folks in terms of that helping people. We didn't evaluate the grayscaling, which is what the Google folks did. So that would certainly be one different direction we could go. We also collected some qualitative comments from the workers while they did the work, which we're currently looking at. You could also imagine intelligently blurring parts of the image perceived to be problematic and trying to do some of that instead of making it entirely manual. And this would be the kind of thing where we could think about, again, AI technologies trying to be designed in such a way to better support workers in the work they're doing. Or you might imagine for different kinds of content that we detected to be more or less problematic, we might handle it in different ways in terms of the level of blurring applied, or potentially even routing more severe content to different annotator queues. Typically at these places like Facebook, they'll have different moderation queues for different kinds of content. And you might imagine people with more training or more resilience might be more prepared to deal with certain kinds of content than others. So with that, let me pause, and if it's okay, take any questions at this point.
Sure. Thanks a lot, Matt. That was really interesting work. We do have a couple of questions from the audience over here. Just to make this nice and flow along fluidly, I'll read these questions out for you and your team. So Jasper here asks, what was the result that surprised you the most?
I think the result that surprised me most wasn't ours as much as Google's. This idea that the moderators really didn't like that blurring, the fact that it was such gave them this headache, and it made us really wonder when we had started this how this would go in terms of the interaction. And so I think we were happy to see it really help with that. But I think that was sort of surprising because, as I mentioned, these blurring interfaces are getting more common in both, say, in Facebook or Microsoft's moderation tool, which I showed. And interesting to see that this evaluation that maybe the moderators were actually doing didn't like it in the way that it's being deployed right now.
Right, thank you. We have Dil Rukshi who asks, was there a ground truth for the images?
Yes. So we collected this image data set ourselves. And so we defined the ground truth on it. Now, when we asked people, would you consider this content safe to be posted? Clearly, there is a subjective element to how people have made that determination. So I think in that sense, we should be clear that this is not a sort of universally perceived ground truth. We don't have inter-annotator agreement statistics on our own annotation of this gold standard, so I also can't report that. So those are both caveats or areas for improvement. But yeah, so we created that gold standard ourselves.
Great. All right, perhaps I could ask you one general question on this body of work, right? That looks into trying to understand how content moderation in general can be made better for everyone who's involved in that kind of work. So Matt, in your experience, what is your take on using participants who are crowdsourced or recruited from crowdsourcing platforms to study the impact of content moderation as such? So what sort of an approximation is this in terms of how reasonable uh, how reasonably they can reflect what content moderators perhaps believe?
Sure. I should also mention too, so for both the works I'm talking about today, I think I said I'll have the students on the call. So Anna Brodo is actually on the call with me, and when he got the same question when he gave the call earlier, so I'll respond and then see if he has anything to add also. So the ideal place to evaluate this is with the actual people who are doing this work in the context they do it. So if you're doing this for 8 or more hours a day, that's certainly a very different experience, days on end, than somebody who just does this for sort of a helicopter experiment on Mechanical Turk, as well as the fact that people who are doing this in these controlled environments for real, they often may be in a closed facility. They may have some sort of wellness or resilience program, in fact. So there's lots of issues about sort of, the typical kinds of assumptions we make as academics for simplicity versus the real stuff in the field. So I think this is interesting. I think there is a real result here for exploration. But of course, if I had a content moderation workforce at my disposal, I would like to do a more authentic integration. I should also say I actually am partnering with a company right now that does have real workers, and we're seeing the extent to which we can actually do that. But I don't have anything to say about that now. Anabrodo, did you want to add anything?
Not much. Just one thing is that it will be interesting to have some sort of participatory design methods applied with these content moderators, and see if we can build human AI partnership systems where from the beginning of not only designing the intervention, also designing the AI tools that might be used in this context, and have the moderators in the loop would be another interesting area to sort of pursue.
Excellent. Thanks a lot, Anubrata and Matt, for getting back to those questions. So in the interest of time,
Great.
I guess we can proceed along. And if any of you have
Terrific.
more questions, please feel free to chime in on the chat, and I'll make sure Matt and his team get down to them. Thank you.
Yeah, we're happy to take more questions about this, of course, at the end. And so we'll just go ahead and move on to the next work as well. And so that work was with Anna Brodo, you just heard from. This work is with Alex, another PhD student who's on the call and can help take questions at the end too. And so this work is a completely different topic. So we're looking now at aggregation of annotations. And I'll also say that there's a NeurIPS crowd science workshop in a few weeks where I'll do an encore version of this talk on the aggregation part. But it's an interesting workshop in general if you haven't seen it. So Simple annotation and aggregation is a really common thing in crowdsourcing. Like one of the very first papers that got the most traction by Ryan Snow and friends at Stanford in 2008 in natural language processing was looking at the fact that while crowd annotations might not be the same as expert annotations, if you just took 5 of them and aggregated them together, you could get sort of reasonable quality at a fraction of the price. And they demonstrated this across a variety of tasks. So classic places where we see this are tasks like classification, where we have maybe sentiment analysis or categorization of text or images, ordinal ratings, where we might have product or movie reviews, or rating the relevance of search. And as Ujwal mentioned at the very start, I got started in this in doing search relevance annotations and kind of broadened out to crowdsourcing more widely from there. Or just like a multiple choice task where you could imagine you have 4 different A through D questions and people might take them and take a quiz. So aggregation has gotten a lot of work in our community in crowdsourcing, particularly because of this issue of quality control. More generally though, even with experts, people talk about the wisdom of the crowd. So there's been various studies, say with doctors, where we consider that nobody is necessarily right, but if we put their different perspectives together, we might get at a better answer than anyone on their own. Or similarly, when I have trusted annotators and I'm kind of developing a new annotation guidelines, I might also want to know a sense of kind of what everyone thinks. So the goal that we're going to talk about in this sort of aggregation work is to select the best label available from all the labels the annotators have given. So one thing that's really widely misunderstood in aggregation is that almost all these models, nobody does label fusion. So if you have 5 labels for a given item, everyone picks the best one of the 5 that's there. They're not actually creating new labels. Very rarely is that the case. So for example, if somebody asks, what's the capital of Texas? You might ask 3 people, 2 people might say Austin, 1 person might say Houston. And if we do simple majority voting, we might say that, oh, we think that Austin's probably the right answer because 2 out of the 3 people said this. And so this is like the most classic, simple way of doing aggregation. And so, but you can imagine a more complex task, like if I ask somebody to say, caption this image, and so I have some kind of cat eating a donut, one person might say a cat is eating, another person the cat eats, the third person a beautiful picture. Nobody has said, nobody here has said the same answer. And so there is no majority if I try to do a simple majority vote. And so typically when all these many papers that have been done, like looking at aggregation, are almost entirely considering these very small label spaces, where if you have enough enough annotators, they'll land on the same answer, and you can do this kind of you can do this kind of simple aggregation. But if you don't have exact match, then it gets more challenging. So with complex annotations, these are tasks like, if I have a set of rankings from annotators, or if I have syntactic parse trees, or these kinds of free text responses, or natural language sequences, as the space of the different annotations gets more complex, it's hard basically for any of these simple methods to work. And so what we're going to talk about is this problem, some prior work in this space, and the usual, our approach, experiments, and conclusion. So this task of aggregating simple labels is probably the most studied problem in human computation. I had a benchmarking study of looking at this back in 2013 or something. And it's the kind of thing I've gotten pretty tired of reading papers when they get submitted, because it's just one more complex model of doing sort of the same task that feels like it's gotten beaten to death. And so it was sort of a work that I didn't think I was going to be doing anymore in this space. And yeah, there's many interesting models that have been proposed looking at things like item difficulty, or you might have hierarchical priors, and trying to model things like, the item difficulty or the annotator behavior. But the problem is, like all these hundreds of papers, they don't support this kind of complex annotation that actually is an interesting thing. And that's what got me back to looking in some of this space again. So what has been done is people come up with a variety of task-specific models. So for instance, I had a PhD student several years ago who was looking at sequence annotations. And so in sequence annotations, we came up with our own particular model for how you handle that case and did all of this benchmarking again. But that's great for sequences. What about for other problems? Okay, so Malsam and Weld have done a lot of great work. They looked at this one about sort of how can you aggregate these sort of complex math problems. So the issue is that like for every different task you're looking into, you need to come up with yet another model, which is like hard and complicated to formulate. And you can imagine that, let's say if you're a company who wants to provide this sort of services across a lot of different tasks, it's challenging to provide all of these different models in practice. Another place, so let me say back up. So this is really what the machine learning side of human computation has been beating to death. On the human computer interaction side of HComp, there's all of this work on workflows, which is like, classic one here is PlateMate. How many calories is this dinner? How can I take this task and break it down into a set of subtasks, which people work on, and then I'll put it together to solve the answer. Or there was one on transcription. This was work by Walter Lasetsky and friends, looking at trying to have laymen be doing transcription by breaking down the transcription task into various parts. So this is basically looking to essentially human computing rather than AI to solve this stuff. But you have the similar problem that you need like a workflow for every task. And this is not easy. And just, one example I always like to give people is, years ago when I worked at Crowdflower, like a third of the company was doing workflow design, because for every different customer and every different task, you had to come up with yet another workflow to try to figure out how to solve this stuff. So the sort of workflows and this task decomposition, this sort of HCI stuff is really complementary to these aggregation models, but you have the same problem that you need to come up with a workflow essentially for every complex task. So it's complementary, but challenging. So in our goals, so we wanted to have aggregation for these complex data types, and we wanted to take advantage of this large body of prior work, but generalize it. And we need to generalize across sort of many different kinds of labeling tasks. So we wanted to not have, all of these different models, but could we somehow have a simpler formulation that would allow us to generalize across them? So let's jump to our approach. So the key insight we had was that for sort of any different kind of annotation, you might think about having a notion of a distance function. So the distance between two annotations and giving people partial credit by how close they are to one another. So the thing that we need to know that is specific to each task is we need to have a distance function for how you map how far apart two annotations are in whatever type. And then the idea is that instead of modeling the annotations themselves, we would model these annotation distances directly. So our aggregation model would only have to work on the distances, and distances generalized across all tasks. And moreover, these distance functions already exist basically in every task you're interested in, because people need to have evaluation functions in order to compare the predicted labels versus gold. So you already have to evaluate how close these predicted labels from models are or from annotators are versus gold. So in some sense, we already have these distance functions readily available to use. So a distance function has some standard properties, non-negativity, symmetry, triangle inequality. And if you look across different evaluation functions, not every evaluation function immediately satisfies these properties, but it's actually pretty easy, it seems like in practice, to manipulate them so they are. So for instance, if you look at tau correlation for rankings, which typically runs the wrong direction, we can just complement it to make it run the right direction. Or if you take like a measure like BLEU for looking at machine translation, it is asymmetric, but this common trick from say KL divergence and information radius is you just basically run it in both directions and average, and then you can essentially turn an asymmetric metric into a symmetric one. So with this sort of trickery, we can turn sort of any evaluation metric into a reasonable distance metric. So for example, if you think of something here like text annotation, so we have our cat eating examples that we looked at earlier. So of all these ones where people say something very similar, if you take a distance function like string edit distance, you'll see that all these ones are very close to one another. Whereas this one that's a beautiful picture is going to be the farthest away from all of them. So what we do essentially is pre-processing before you do any aggregation modeling is just to convert these annotations into this matrix of these distances. And then, so you can take sort of any of these different kinds of tasks and convert them into these matrices where you look at the distance between two annotations on that particular item. So how do we aggregate then these things? And we'll talk about, or I'll talk about a local selection, a global selection, and a combined model. So the local approach we call smallest average distance. So this is like the generalization of majority voting. This is not a trained model or anything at all. You just take the current item, which has some set of labels. You look at the average distance of that item, that label to all other labels, and you pick whichever annotation is the closest to all the others on average. Again, so this is the generalization of majority voting is typically based on exact match. This is a generalization to where you have partial credit matching. So you can just look at any single item and just say on that one, which annotation is closest to all others and just pick that one. So that's very simple. You don't have to deal with any issues about training a model, and then every item is handled on its own. So the version that's more global, we call best available user. So for every item that's being annotated, you just say of all the annotators that did it, which one has the best accuracy on average? And we'll just pick that annotation from that item, regardless of whatever it is. And so in that sense, we look over the whole data set. In general, we see, we see which annotator is closest to all others on average. And then for all the people who annotated this item, which one is the best one available? So this pays no attention to the local context of how good the annotation on this item is, but it tells you on average, which annotator is best. So that's the global and the local. Can we somehow get the best of both worlds? So can we get ones that are close on the local item and sort of a worker who does well on average? And this looks kind of like this weighted voting we're used to seeing with these aggregation models. And we'd like to build on all this rich history of Bayesian annotation models with some kind of principled framework. So Alex's great insight here was to work on multidimensional scaling as the foundation for this. And so we'll have a probabilistic model of these distance matrices. We'll have a hierarchical Bayesian model like you've had in this traditional work with priors versus the likelihood. And let me just jump into it. So for instance, we have this idea here of, again, a cat is eating, like we've seen, these ones are close, these are far away. So we're going to look at this notion of the observed distance. And with multidimensional scaling, we're going to be embedding these into an embedding space where things that are smaller, have smaller distances, will be closer to one another in the embedding space, whereas things that are farther away will be actually farther away in the space. And so you get a mapping like this, where again, these annotations are all now very close, whereas this one is farther away. Now, that's just the likelihood part. The prior is to have this notion that the pseudo goal that you're trying to get to is at the origin in this space. And you want to penalize the model for putting things that are close to one another far from this origin versus labels which are very, very different. And so when we take advantage of this term, then we get these items that are close to one another getting pulled closer to the origin, and this item, which has the most different label, being farther away. And just trying to keep an eye on time here. I think I'm going to just jump ahead a little bit. So that's the long and short of it. Yeah, I'll say more later. So we look at this on 4 different data sets. We have 2 synthetic data sets. One is these syntactic parse trees from linguistics. One is these, we look at rankings. And then on real data sets, we have these biomedical text sequences where people are doing span-based or sequence annotation, and machine translation, or in this case, the human annotators who are translating between Urdu and English. And this was a data set Chris Kalsenberg kindly shared with us. So baselines, random user is you just pick one label randomly. So this is as if you only had one worker do the task. How well would you have done? We took Zen Crowd from Gianluca De Martini is just a classic example of one of these well-known aggregation models that depends on exact match. And we don't expect it to do very well in this space because you just don't have exact match, because almost every annotator says something different. And so models that are trying to do weighted voting based on exact match aren't going to learn reliable weights. In the sequence model in particular, we were curious how well our general model compared to a model that was specifically optimized for just the sequence annotation task. And then we also considered an upper bound oracle. So this is given the 5 annotations for an item, it will just always pick whatever the best one is by cheating and looking at gold. And note that the oracle is still upper bounded by the 5 workers who answered it. So maybe none of them gave the right answer, but we'll just pick the best one of all the 5 that say they were provided. So on these 4 tasks, translation, sequences, parses, and ranking, we have a different metric for each one. And again, the evaluation metric we're using aligns with the distance metric we use for translating the annotations into annotation distances. And we see that there's a varying difficulty. So for instance, the random user on translations only gets about 18%, whereas on parses, the random user gets about 81%. So some range of difficulty in these. And if we look at the oracle, you can similarly see, range of how well you can do in the best possible case. So the difference between the random user and the oracle. When we look at the Zen Crowd baseline, it's almost the same as the random user. And again, I want to emphasize, this is not because Zen Crowd isn't an awesome aggregation model, but it's based on assuming that you have a small annotation space where you'll have exact match, and based on exact match, you can learn who's more reliable. When you don't have exact match, these kinds of models just break. In terms of the sequences in particular, we have this much stronger baseline from the model that we had published in the past. When we look at the general model we have, it does, in general, better, which is why we get to talk about it here today. But the thing that surprised us most of all, which was the question I got from the last work, was we really didn't expect this general model to do as well as the task-specific model we had generated for sequences in the past. So this was the one that really surprised us here. The general story, we tell on this work is that you can expect that, if some task is really important to you, you're going to do a lot of it, it's worth a lot of money, let's say, you're going to be better off probably generating a very custom model or a custom workflow or something to optimize it. But like the first step is, before you do that, take this general model, which just works on everything, and use the general first and see if it's good enough. So now you have an option to just sort of aggregate this way in general and only go up to the custom model if you really need that later on. So we were surprised in this case where we actually did as well as that. So I think I'm about at time I should stop for questions. So I'll just quickly say, some things we're looking at going forward is we're generalizing to more tasks, say like image bounding boxes or key points. We're looking at how well this model works on simple annotations and complex annotation tasks. So can we have one aggregation model that really works for everything? Can we support these tasks where you don't just have one single thing to be annotated per item, but multiple? So for instance, in a bounding box task, you might have 17 different objects in the image that need bounding boxes. How do we do aggregation well on a task like that? Or this case, as I mentioned at the very start of here, on label fusion. So can we do better than just picking from the set of labels that are available by actually putting labels together? And a variety of other stuff I don't have time for. So with that, I'm going to stop and then invite Alex also to join us. I think he's here to take any questions along with me. So thank you all for having us here today.
Thanks again, Matt. That was another piece of very interesting work. And we do have a lot of questions that have floated in. Let's try and get down to them. So Meng Lee here asks, how do you assign the value to different texts? So I believe this is
how do you assign the value to different texts?
So this is probably about the distance functions.
Yeah, I think I saw this question pop up when we were showing the numbers pop up. So it's actually there's no numeric value being assigned to text. So one of the things that it's hard to take a complex annotation and convert it to a number. So that's why we introduced the distance modeling on the distance. So the number is for any pair of texts. And in this case, to tie into some later questions, in the example where we do look at text, we're using the glue or the blue score. And I think there's going to be some redundancy in this answer with some of the subsequent questions. But does that answer this one from Meng Li?
I mean, I think, again, the thing I would always tie this back to is in any task, you probably have an evaluation function, because how well do you know how well your model does, or how well do you evaluate your annotations versus gold? So if you have that evaluation function, then with maybe not too much work, you have a distance function for saying how far apart two annotations are. And that's what we're modeling. It's that distance between them, not the annotations themselves.
Mm-hmm. Right. Manuel asks, what do you think would happen if you remove poor global annotators and then do a local selection?
Yeah. So go ahead, Alex.
No,
you take
no,
it.
you can. Okay, well, we can both go. But so my take on this is that this is again a combination of trying to take a global information, the local information, and it's, you know, there are a lot of kind of these, I guess you might call like heuristic approaches to doing that might work. I think with this one, the questions that would pop up if you try to do it this way are, how do you set the threshold for what a poor, you know, a poor global annotator you'd think is someone that globally, on average, the distance is too high, and so how high is too high for them to remove is one. And the other difficulty in our model, we end up modeling item difficulty, because for some items versus others, there's just a natural larger distance, and if you take an approach that doesn't model that difficulty, you might kind of you might end up penalizing workers for having large distances on particular items, even though that item, they didn't do particularly badly in that item.
I would add a little bit that, you know, in some sense, I think it's a fair question that the aggregation model here is doing two different things, potentially, you know, filtering out really unreliable work versus trying to do a wisdom of crowds between sort of what's left. So you might think about trying to do division of concerns. And just as one practical example, so I mentioned Amazon, for some of you who were here early. So Amazon has a product called Ground Truth, where they curate the Mechanical Turk workforce. So for instance, if you use Ground Truth to annotate with Mechanical Turk workers, you get a curated workforce versus using Mechanical Turk directly, where you just sort of get all workers. So certainly is an approach that a number of platforms take to try to curate their workforce as part of their secret sauce to delivering quality.
Thank you for the answer. We have a couple of other questions from Jay, who also happens to have some privileges. So I guess Jay might want to ask the questions himself.
Yeah, sure. Thanks. Thanks, Matt, for the presentation. So my question is regarding the use of the approach. So in the application of the approach, does the requester have to select the distance functions themselves? And if that's the case, how hard it is, you know, to explain how the distance function works to them so that they can make informed choice?
Yeah, so I think it's a great question. It's certainly one we haven't done in any significant way, but I think the argument, you know, basically I would give is, again, presumably you have an evaluation function for your task, because let's say you go and either yourself do it yourself or pay somebody to give you annotations. How are you going to know if those annotations the person gives you are any good? I mean, you have to have some evaluation function that principally you're using at the end of the day to evaluate the quality of that. So if that is the case, the idea is we can just reuse that same evaluation function for this distance. So I think in some sense, it's not a very heavy lift, given that you, in theory, already have an evaluation function like that existing. But I think that is still a fair point. And one of the things we've talked about, but we haven't done much of, is looking at, you know, the distance function that we use internally, to the extent to which if you choose to use something that's different than the evaluation function at the end of the day, does that divergence really affect quality very much downstream? Alex, do you want to add anything?
Yeah, and I will say we in the code that's publicly available, we've added a couple of things to try to help people along. You know, who we're assuming they're not going to reach out and or they shouldn't have to reach out and contact us in order to use the code. So if the easiest thing is for them to provide the evaluation function, which presumably they have, and then the code will automatically detect, try to make it symmetric and try to make it, going in the right direction and satisfy those three constraints. And if for whatever reason it doesn't, it will give you an alert like, oh, this doesn't satisfy triangle inequality or something like that.
I see, thanks. My second question is a very quick one. So has this aggregation function been integrated into MTurk?
Oh, I couldn't comment on that either way, certainly. But I will say that again, that we've released this in open source from UT Austin with a license that permits any company to use it freely without royalty. So we're hoping that the kind of work we're doing can be adopted and have practical impact beyond us publishing papers.
Okay, thanks. That's good enough for me.
Great. So Matt, if you have another minute, I have one last question that was left unanswered, and we'll need to circle back to the previous talk for this one.
Sure.
So Deepak here asks about how there are already a lot of moderators working with Facebook and YouTube, but whenever we post content, we immediately see that it's becoming public. So moderation is clearly being performed for selective content. So do you know if, or comment on whether there are some automated techniques, I apologize, that are being used for this task?
Yeah, so Facebook has been good recently in starting to publish quarterly reports in terms of moderation takedown. And they'll talk, for instance, about the amount of content that's automatically approved or rejected without any human intervention. So they don't report anything about the percentage that goes to, they talk about how much in total absolute gets approved or rejected without human involvement. They don't talk about how much goes to human moderation or what the percentage of their workload is. So it's certainly true that some of the stuff does happen automatically, and it's unclear what the exact percentage is. The Facebook archive report from 2 months ago also isn't specific about that. One quick thing I'll say is a nice example where companies have come together is around case like what's called photo DNA. So if the same image gets recirculated later, which often happens, and people have stored that image already in a database, then when it gets posted, you can just automatically, by a simple bit check, make sure it's the same and block it from being posted anyway. And this is a case where, as I said, across different companies, they found a way to partner on this because it's in sort of everyone's collective interest to stop that. And so some of the work that I'm trying to do now with some of these companies is to similarly come together as a consortium to share best practices here so that everyone can benefit in terms of tackling this collective problem on how we keep this kind of content off the internet, as well as care for the moderators who are absolutely necessary to do the work today.
Excellent. Thanks a lot, Matt, once again, and Anubrato and Alex for being here with us. That was, I think, a very nice session, and I thoroughly enjoyed it. I'm sure everyone who joined us here shared the sentiment. So thanks a lot, Matt, and yeah, I look forward to seeing you around. I'd like to remind all of you who've joined us today that we have another talk next Monday, and we have talks every Monday. Sometimes we need to reschedule the time slots because clearly we have speakers who are chiming in from across the world. Next week, we have Gianluca who's joining us, and this would be at 9 a.m. CET. I hope you'll all be there with us again. Thanks a lot once again, Matt, and see you around.
Thanks for having us. Take care. Looking forward to the rest of the series.